group derived the equation by first measuring the box. It had a width of 15.5 inches, which would end up being our 4A, the width of the parabola opening. We wanted our parabola dish to open up, so we used x squared equals, along with a positive 15.5 and a vertex of 0, 0, which resulted in our equation of x squared equals 15.5y. To construct the dish, we covered the inside of the cardboard box with aluminum foil. We also covered a piece of construction paper that fit into the box while curved up like a parabola with aluminum foil. This was all taped together with colorful duct tape. And then we stuck a shish kebab skewer that was stuck into the side 7.75 inches from each side of the box and at a focus height of 3.875 inches. These numbers were found by getting the 2A value, 15.5 divided by 2, and the A value, 15.5 divided by 4, making our focus coordinates 0, 3.875.
The independent variable is time, and the dependent variable is temperature. The domain is x is greater than 0, and the range is y is greater than 0.
As you can see, our graph increases when we start and then it dips a little bit and then it decreases towards the end and it doesn't go up again. Dips in the graph could have been caused by changes in the weather like clouds over the sun or wind over an amount of time that could change the temperature around. And also we had problems with what our marshmallow was on. The stick that was in our graph was falling sometimes, so that the sun might not have hit it directly like we planned.
Leah's group was the hottest with a final temperature of 55.5 degrees. They were on the steps and had a clear path of the sun, so that probably helped them. But most of all, their structure was a bowl. This is why their model conducted the most heat. It also modeled their equation very well. Our group actually conducted the least amount of heat. This was probably because our model was a box, not a bowl like the majority of the other successful groups. Our marshmallow and stick also seemed to get weighed down from the temperature probes, making our focus point a little inaccurate at times. So that is why we probably were the least amount.
Some design features that affected the heat generation of the parabola would be the shape of the parabola and also the materials used in the parabola. So in our parabola was made in a box, while other parabolas were made in like bowl shapes, and we found using the data that we collected that the ones that were shaped as bowls actually generated more heat towards the marshmallow in most of the cases. And the materials used to build the structure also affected the heat generation. We used a cardboard box which we covered in tinfoil, but other groups used like reflective paper, and the reflective paper actually worked better than the tinfoil. The tinfoil didn't absorb as much heat towards the marshmallow. Although we weren't really able to measure how well the equations matched the structures, you could kind of tell based on the measurements if they matched the structures. The structures where the equations matched the most heat was generated because the focus was more exact, and that had an impact because if the focus was more exact, then that would be where the energy from the sun, the heat from the sun would be directed, and then your marshmallow would be able to be cooked faster. So the equation really had an impact on the heat generation from the structure.
We had in mind what our structure was going to look like before we built our parabola, but we made our equation before we started assembling it. I think it is a lot more beneficial to start with your equation because it allows you to be more precise with your measurements. Starting with the building of the structure can lead to more mistakes. I think if you start with the structure, it is harder to even figure out what your equation is. For groups in the future, I would recommend starting with the equation. We were successful in this way and were able to easily match our model to the equation.
The most difficult part about this project wasn't actually making the parabola or the dish, because we had all the supplies already. The most difficult part was actually working together and finding a date that would work best for all of us. I actually wasn't able to make the time that our group created the parabola dish. Kind of leaves me clueless, and communicating and spreading information between all the people in our group was probably the hardest part about the project. The ways that we solved this was that we created a group chat and allowed us all to talk, and after they created the dish at someone's house, they told me what happened, and this kind of informed me, and I was able to learn what I missed. If I were to advise a company on how best to build a parabola dish, I would first recommend that they use a high A value. This creates the right shape and dimensions for their parabola dish, and it gets and captures the most sunlight. I would also recommend that they point their dish towards the sun in order to get the best angle and to absorb the most sun, and I would also recommend that they use as much reflective material as possible. I'm sure a big company could probably afford something better than aluminum foil, so that would be the best idea.
These recommendations are supported by Leah's group and the success they had roasting their marshmallow.
Future advice that we would give students to work on this next year is to plan with your group members before you convene what you're going to do, so you can gather your materials and have them ready and get it done, so you're not just wasting time planning it out. Another piece of advice we had was to not overcomplicate things, because even the simplest parabola dishes exceeded the temperatures that we had, which was really interesting too.